Okay, so this is the semester 1 final review for Algebra 2 we're doing 2023 to 2024. It's going to go kind of rapid fire as I go through this, so feel free to pause it wherever you need to. We'll also go over this in class if you're there in class for this session. So question number 1, we're trying to take the square root of negative 90 and simplify it. A couple things to keep in mind when we split these. We got to split them because it's a square root by the perfect squares, which are 1, 4, 9, 16, 25, 36, 49. Now 49 is more than half of 90, so I know that's out. You could check 90. Does it divide by 36? The answer is no. Does it divide by 25? No, that'd be 100. 16 does not go into 90, but 9 does. So that means that I can split this as the square root of negative 9 times positive 10. I'm going to put the negative with the number I know the square root of, because the square root of 9, while it is 3, the square root of negative 9, we can't take the square root of a negative traditionally, but as we advance in our mathematics, we learn that that negative means that we're going to have an imaginary number. So the square root of negative 9 is 3i, and we have a leftover root 10. Okay. Again, you have to use this split, these perfect squares to make those splits happen. Number 2, we're going to continue to work with imaginary numbers. 4i times 2 plus 9i minus 26 plus 4i. So we have a little bit of distribution to do here. This 4i needs to multiply through our first parentheses, and this negative is really like a negative 1. Let me grab a different color here. So we're distributing a negative 1 through. If it was a positive 1, that distribution doesn't change anything, and so we would leave it the way it is. But here, 4i times 2 would be 8i, and 4i times 9i would be 36i squared. And we have negative 1 times 26 is minus 26, and negative 1 times 4i would be negative 4i. Before I try to combine my like terms, we need to acknowledge that I squared has a value equal to negative 1, which means this problem can be rewritten as 8i plus 36 times negative 1. Instead of an I, we can replace I squared, we can replace it with a negative 1. Minus 26 minus 4i. The 36 times the negative 1 right here becomes a negative 36. And we can now combine our like terms. It's best to put your real numbers first. So negative 36 minus 26 is negative, I believe, 62. You can combine that in the calculator, and then 8i minus 4i would be a positive 4i. And we are done. We're just combining our like terms and simplifying the imaginary values as they come. 3, 4, and 5 are all about factoring quadratics, x squared minus 7x minus 18. When we factor this, 2 sets of parentheses, the x squared can only split as x and x. There are lots of ways to split the 18, 1 and 18, 2 and 9, 3 and 6, but we want to know which of those subtract to give us 7. The answer would be 2 and 9. Now the 18 was negative, which means that my signs have to be different. I'm going to have 1 plus and 1 minus. In order to get a negative 7, I need a big negative, so negative 9, and a positive 2. Notice this does not ask you to solve. The instructions on the review just say factor, so we are done. We could go a step further and solve, but that's not what we're asked to do here. If you did, I wouldn't mark it wrong as long as the factors were there first. But don't overkill just because you can. 2x squared plus 9x plus 10. I'm going to take the approach that we talked about this year in class, making brownies, where we fudge the numbers a little bit. This 2 is going to times over by the 10 to make my problem now x squared plus 9x plus 20. We do that whenever there's a number in front of x squared. All right, so now we go to factor. X squared would split as x and x. How are we going to split a 20 so that it adds up to 9? Well, the answer would be 4 and 5. We'll put a 4 there. We'll put a 5 there. The 20 was positive, so my signs have to match, be both pluses or both minuses, but to get a positive 9x, I'm going to need a plus and a plus. This is where we have to correct. We call this making brownies because we fudge the numbers a little. This is not the correct setup. because x times x is not the 2x squared. So I now need to go back to the next stage of the problem. I have to clear out that multiplication that I did by 2. I now need to divide by 2. Well, 4 divides by 2 nicely to make x plus 2. But 5 doesn't divide by 2. And because it doesn't divide by 2, that 2 gets to go sit with our x. So we don't have a fraction in the problem. And there's our final answer. So remember, we make those brownies by fudging the numbers, and then we have to correct it at the end. All right, question number 5 is actually just a special pattern, x squared minus 81. Notice the middle number is missing, which is the equivalent of saying you have 0 x's in the middle. Whenever you see this subtraction, this difference of squares, we know the x will split as x and x. How do you split an 81 so that when you minus, you get 0 x's? Well, the answer would be 9 and 9, the square root of 81. If I add 9 and minus 9, because the 81 was negative, I should have the right combination. Question number 6 takes us to a problem where we're trying to do the same approach, but we can't factor it. And we want to go the extra step and solve it. So question number 6 is going to rely on the quadratic formula. 3x squared minus 5x plus 8 equals 0. Let me be abundantly clear. This will require you to use the quadratic formula. There is no way around it. And so our a would be 3, our b is negative 5, and our c is 8. And the quadratic formula, of course, is negative b plus or minus the square root b squared minus 4ac all over 2a. Hopefully you can read my handwriting on that. But we're going to take negative b. Since b is negative 5, the negative of b would be positive 5 plus or minus square root b squared. Now, I'm going to tell you right now, don't write negative 5 squared. What is negative 5 times itself? Well, that's 25 minus 4 times a, which is 3, times c, which is 8, all over 2 times a, which is 3. Into the calculator, I will put the inside of the square root, not the square root itself. I know 2 times 3 is 6 on the bottom there. But if I take my calculator and I do 25 minus 4 times 3 times 8, whoops, that's supposed to be an 8, I get negative 71. And this is where I go back to that very, very first problem and ask, does it divide by 4, 9, 16, 25, 36? 36 is bigger than half of 72, so it's out. 25 does not go into 71. If it's an odd number, all the evens are off the list. And 9 goes into 72, not 71. So this doesn't divide at all. There's nothing to pull out of the 71. But I also am not going to leave a negative inside my root because I know that negative, square roots of negatives are always imaginary. So this would be I root 71, where the 71 is now positive, all over 6. If I'd pulled something like a 2 out and the 3 numbers outside reduce, then I can reduce. But this is an example of a problem that does not go any further. Question number 7 is really an application problem to question number 6. So you've got a deck that you want to increase the floor's area by adding the same distance to the length and width. The original size is 9 foot by 12 foot. So 9 by 12. I want to add some distance, call it x, to the length and the width. I want it to be the same that I add. Okay? The new dimensions are not going to be equal dimensions, but I want to make sure I'm adding the same amount to the length and the width. I want my new area, which is length times width, x plus 12 times x plus 9. I want the new size to equal 304. In order to solve this problem, I need to turn it into a nice quadratic, set it equal to 0, and solve from there. So I'm going to have to do some multiplication here. X squared plus 9x plus 12x. And 9 times 12 is 108. and that equals 304. For me to solve this, I need it to be equal to 0, so I'm going to minus the 304 from both sides. And I can combine these like terms while I'm at it. X squared plus 21x minus, is it 196? 108 minus 304. Yeah, it's negative 196. 196. And that's all equal to 0. You can use the quadratic formula here. You can try to factor it. There's really no guarantee that the problem you're given will have a perfect nice whole number or even a decimal that's a nice decimal. So you really should default to using the quadratic formula. However, I understand if you're more likely to want to factor it. But 196 is a tough number to work off of. So I'm going to use the quadratic formula. A would be 1, B would be 21, and C would be negative 196. So quadratic formula is negative b, negative 21, plus or minus the square root of 21 squared minus 4 times a, which is 1, times c, which is negative 196, all over 2 times a, which is 1. And so I grab my calculator again. 21 squared minus 4 times a negative times 1 times negative 196 is 1225. So this comes out as negative 21 plus or minus the square root of 1225 all over 2. Now this is really important you understand the distinction here. Here I'm actually going to measure this distance. I have to actually build the new framework for this floor. I can't use square roots for the rest of my life on something like this. We actually have a context, and this context tells me I'm going to take a measurement. Because of that, okay, this is the only time you're allowed to do this on this test. When you have context, you can put this square root in the calculator. Normally we do it by hand, but here, even if it doesn't come out nice, I'm going to use a decimal. Now I think this one comes out clean, but even if it doesn't, if it came out as 17.38, some number, you would still use that number. Round out a few decimal places, but it would be fine. So I'm going to take and do the square root of that number, 1225. It comes out as 35. Now that is great. It is not guaranteed that it's going to come out as a nice number. But because of the context, you need to have a number. So that 1225, the square root of that was 35. And now I'm going to do the plus version and the minus version to produce my two answers. Negative 21 plus 35 is 14, but that 14 needs to be over 2, which makes it equal to 7 feet. Or if I do negative 21 minus 35, that would be negative 56 over 2, which is negative 28 feet. Under no circumstances should it make sense to say let's minus 28 feet. So the context tells me that negative 28 feet doesn't make sense, but it is mathematically true and valid. But what makes sense is for me to say let's add 7 feet to both measurements and we'll get the 304 square feet we're looking for. Okay, turn the page. Question number 8. This test review is going to get split into 2 sections. Okay, we're going to make it through probably question 12 or 13 and stop there, and then we'll do the second half in a second video. Otherwise these videos just get too long. But question number 8. Okay, we have 2 equations, y equals negative 2 parentheses x plus 7 squared minus 5, and y equals negative 1 times x plus 8 squared minus 3. And we're being asked which one has a larger maximum. Because these graphs, or these equations, are negative in front, that means that we're looking at this upside down parabola. And what we want to know is which one is up higher. Well, if we just go and find out the 2 vertex or the two vertices, the vertex for each of these equations, then we can compare them. If you remember that when we do the vertex in this pattern, it's the opposite of the number with x, which would be -7, and then whatever number's at the end of the equation, the way it is. So -7, -5, and our second one would be -8 and -3. But when we say which one has a larger maximum, we're asking which hill is taller. If you think about a coordinate plane, right? This first one's at -7, -5, sitting right there. -7, -5. The second one is at -8, -3. -8, -3. So who's up higher? Well, the -8, -3 is, and so that's all I need to do. Is identify which one is taller. Staying with this idea of working with a vertex. Question number 9. You have an equation. Y equals x plus 4 quantity squared plus 5. It says thinking of the vertex, so let's start by identifying the vertex. The vertex is the opposite of what's with x. So the vertex is the opposite of what's grouped with x, which would be -4, and then whatever number is added at the end, 5. Okay, it says what would the equation be? So I want to rewrite this equation. If I move the vertex down 2 units, down 2, and 3 units to the right. Well, to me, this is going to be a lot easier on a coordinate plane. So I'm going to find -4, +5. Just going to put a little dot up here, and I'm going to move down 2 and over 3. So if I was at 5, that was the height I was at, and I went down 2, that would put me at 3. So I'm now going to be at 3. And my x, I started over here at -4, but I'm going to the right 3. So I'm going from 4 over to, sorry, -4 over to -1. So I would put me at -1 now. So get the right placement of your new point, and then I can write the equation. If it was x plus 4, because I was using a -4, then a -1 would be x plus 1, right? We switch the sign for the one with x, and we keep the other one exactly the way it is. It's +3. So there's our new equation. Okay, question number 10, easiest question on the test. We've got y equals, or f of x equals x to the 6th minus 3x cubed plus 12x squared plus 3. We're asked, how many zeros will this have? We just find the big exponent, whatever it is, and that's our answer. Whatever your biggest exponent is, that's called the degree of the polynomial, and that is your number of zeros. All right, question number 11, 12, and 13 are all still tied to this idea of polynomials. So number 11 says we've got x to the 3rd plus 4x squared minus 12x minus 8. And we want to divide that equation by x minus 5. So we're going to use synthetic division, which is the one where we set up the box. We got the bouncer, all that stuff. The bouncer is always the opposite of what's with x if it's in a grouping. So I'm going to come over here, say that that's going to be a +5. The numbers across the top come from our terms here. X to the 3rd is 1x to the 3rd. X squared is 4x squared. The regular x is a -12, and the constant at the end is -8. With a box to catch my remainder, I can go through the process. The first number always drops straight down. 5 times 1 is 5. 4 plus 5 is 9. 5 times 9 is 45. -12 plus 45 makes 33. And 5 times 33, I want to make sure I get this right, is 165. If I add the -8, I'm going to get 157. All right. We now to put all of our x's back into the equation. Since it was originally an x cubed, this 1 is now x squared, which makes the 9 be a regular 9x and a plain 33. We're going to add our remainder as a fraction. It's 157, and I couldn't divide it by x minus 5. Thing I was trying to divide with the whole time. Okay, so that's what 11 should look like, just a synthetic division. Number 12, a little bit of a brain break where we're not having to do anything crazy hard, but let's just be careful. Make sure we go through the normal steps of simplifying along the way. 3x minus 5 plus 3x squared minus 19. All right, just some simple distribution. We've done this earlier in the test with the imaginary numbers. Now we're just doing it with x's. X times 3x would be 3x squared. X times negative 5 is negative 5x. 5 times 3x is 15x. And 5 times negative 5 is negative 25. Over here, this is a positive one, which when distributed won't change anything. So that's still a 3x squared that's positive, and that's still a minus 19. Only thing left to do is combine any like terms. 3x squared and 3x squared makes 6x squared. Negative 5x plus 15x makes a positive 10x. And negative 25 and negative 19 makes a negative 44. And we're done. No solving, it's just simplifying it down. The last question for this half of the video is going to be question number 13, where we are asked to find all of the zeros of a polynomial. The equation starts out f of x equals x to the third minus x squared minus 5x plus 6. The first thing I need to acknowledge is that there are 3 zeros, as evidenced by the big exponent. And for me to find those zeros, I'm going to start with a graph. So I'm going to grab my calculator, and we're going to graph this right now before we do anything else. So we go y equals, clear out what's there, x to the third minus x squared minus 5x plus 6. If I graph it, it clearly crosses 3 times, but I can't quite tell what they are. That looks like it's in between 2 numbers, so I'm going to come look somewhere around 1. Let's look at the table for some confirmation. 2 produces 0. That much I'm sure of, but I don't see 0 anywhere else, but I know I can use 2. So I'm going to say x equals 2. There might be more than one that you can find that are obvious whole numbers, but we're only looking for the whole numbers. As long as you can get it down to 2 answers left, you're okay to proceed. So I'm going to use 2 as my bouncer. I'll do 1, negative 5, and 6 as my values. The first one drops down. 2 times 1 is 2. Negative 1 plus 2 is 1. 2 times 1 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. And that adds up to be 0. Because I'm looking for 2 more answers, right here I can use the quadratic formula with A, B, and C. If I was only looking for 1, there's an easier way to do it, but quadratic formula on these 3 values will always work. So in this case, negative b is negative 1 plus or minus the square root of b squared. That'd be 1 minus 4 times a, which is 1, times c, which is negative 3, negative 3, all over 2 times a, which is 1. So this becomes negative 1 plus or minus the square root of something over 2. If I do the 1 minus 4 times 1 times negative 3, that comes out as 13. 13 does not divide by any of my perfect values, so this is my second and third answers. The plus and the minus produces 2 answers. I already had x equals 2. All right, good luck. We'll see you guys in class, and I'll get the second half of the video posted.